Hello children, welcome to 7th Science online classes. Chapter 14, Electric Current and its Effects. So in the last class we studied the symbols of electric components. We studied the symbol for an electric bulb, the symbol for switch in on position, off position, battery, wire, electric cell, like that. And we learned some electric circuits in off position and on position by using this symbol. And today we are going to learn a very important topic, that is the effects of one of the effects of electric current, that is heating effect of electric current. Effects of electric current we can divide as or classified as two, mainly classified as two: heating effect of electric current and magnetic effect of electric current. So this is very important. Okay, so these are two important effects of electric current. Electric current effect, two effects. These are the two effects: heating effect of electric current and magnetic effect of electric current. So these effects have many applications in our daily life. So today we will see the heating effect of electric current. Heating effect of electric current. So before going to the definition of heating effect of electric current, first we will see this about the bulb. The filament of a bulb is a coiled wire. So you know that this is the filament, the coiled wire. So that is a wire, coiled wire, and that gets hot when electricity is passed through it. So when electricity passes through this, it gets hot, and when you touch the body, outer body, that time also you can feel the hotness. So this makes the filament glow, and as a result light is produced from the bulb. Okay, so that effect, so when electricity passes through it, that time it heated. So that effect is called heating effect of electric current. So we'll read that definition. When an electric current passes through a wire, the wire gets heated up. This is known as the heating effect of electric current. Got it, children? So the definition is important. When an electric current is very easy. When an electric current passes through a wire, the wire gets heated up. This is known as the heating effect of electric current. See, when in your house, the refrigerator, when you touch the body of the refrigerator, when it's working, that time when you touch the body, you can feel the hotness. Okay, why? Because the electric current is passed through it. That is why. Okay, then the heat that is produced in the wire depends upon the following factors: the material of the wire. So all materials are producing the same amount of heat when electricity is passed through it? No, different materials are producing different amount of heat. Example, this wood and metal. Which material produce more heat when electricity passes through it? Definitely that is metal, because the electricity is not passed through the wood but through the metals, and metals also, some metals produce more heat than other metals. Okay, so that is the first one, the material of the wire. Second one, the length of the wire. If the length is more, heat is also more. Got it? The length of the wire is more and electricity is passed through it, that time heat is also more. And the next one, the thickness of the wire. If the thickness is more, that time the amount of heat is less. The thickness of the wire. So you just understand these three are the factors. These three are the factors that depends upon the heat produced. Which are the factors? The material of the wire, the length of the wire, the thickness of the wire. Now we will see what are the merits of, or what are the advantage of this heating effect of electric current. Many appliances work on the heating effect of electric current. Examples: electric heater, electric iron, electric stove, toaster, hair dryer. These all things are working in the principle of heating effect of electric current. So all these devices, all these appliances inside some coils are there. So first we will see, take this iron box or electric iron or iron box. So this is the opened iron box, and you can see this is the coil. Okay, this is the coil, and through this the electricity passes, and this heated up, this coil heated up, and we get the heat for ironing the dress, ironing the cloth. And this is the electric stove. Here also you can see some coils, and this is a electric heater. This also you can see the coils, and this is a room heater. Inside some coils are there, and when you plugged that heater or that room heater to the electricity, these coils heated up and we get the hot or warmth. Okay, and toaster, hair dryer, these all are working in the principle of heating effect of electricity. Now, all these elements produce a high amount of heat when electricity passes through them. However, this amount can change depending upon the requirements of the device. This is so because they contain a coil of wire known as an element. So I told you these are some coils, and these coils are called what? Element. Okay. So this amount can, the amount of heat depending upon the requirement of the device. Okay, and depending upon the amount of heat required by such appliances, different types, sizes, and length of wire are used in them. In some cases, in some appliances, we need more heat, so that time we can increase the length of the this element, and we can thickness also we can change the material. Okay, anyway you can change the amount of heat. That is depends upon the different appliances. Next, what is an electric fuse? So this is very familiar to you in your house, this electric fuse. See, an electric fuse is a device that is used to prevent the damage that can be caused by an excess of electric current. According to the heating effect of the electric current, a wire becomes hot as current is passed through it. However, if an excess of current is passed through a wire, it can melt or break. So I will explain once again. So this is a fuse, and here you can see one fuse wire also, fuse wire, and that fuse wire, you know that electricity passed through the wire, it heated up. Okay, and when in our houses or in house, the electricity is passed more, electricity that amount of electricity is more, that time the fuse breaks, melt and it breaks. So it breaks means electricity is not go to that circuit. So that time we can save our appliances, electrical appliances in our houses. Okay, the electric fuse consists of a wire which is made from some special materials, melt quickly and break when a high current passes through it. As the wire breaks, the circuit of the fuse opens and hence no current passes through it. So in our houses or industry or anywhere, the electric fuses are the safety measures. Okay, otherwise large amount of electricity come and it will damage our electrical appliances. So this is also another kind of fuse. Different kinds of fuses are available, and this is one kind of fuse, and this can prevent a short circuit for fire due to high electric current. So if it is the fuse is not in the correct way, so what will happen? High electric current comes, and it it is the reason for the short circuit, and it catch fire also. Okay, so different types of fuses are used for different devices. So these are two types. And how can excessive current pass through a circuit? We will see the reasons. Sometimes we connect different devices to the same socket. You can see in the picture many devices in the same socket, which results in drawing of more current from that socket. As a result, the load on the circuit increases, and it can lead to a short circuit or fire. Okay, so one socket and many devices in the same socket, so that is the reason for the short circuit, and that short circuit lead to the fire also. When the next reason, when the insulation of wires gets torn away. See, here you can see this is the insulation. This is the metal wire. Through this wire, copper wire, electricity passes, and for our safety, this metal covered by insulators. Okay, and these insulators gets torn away, then the wires can come in contact. See, these wires come contact each other, which cause a spark or may lead to a fire. That is the short circuit. So here also, this from this wire and this wire is touch or contact with each other, it may cause the short circuit. This is why fuses are used to prevent any kind of short circuit and overloading. Next is miniature circuit breakers, or MCB. This is also familiar to you in your houses. A miniature circuit breaker, or MCB, is generally used instead of fuses. So nowadays that meter box, you can see in the electricity meter box in your houses. So nowadays it is changed like this: MCB, miniature circuit breakers. These are switches which automatically turn off when current in a circuit exceeds the safe limit. So first we studied about fuse. So that fuse wire, when excessive current passes through it, the fuse wire melt and it break the circuit. And nowadays that fuse changed to this MCB, that is miniature circuit breakers. So here there is no wire, there is some switch. Okay, so excessive amount of electricity passed through this switch off. Okay, turn off when a current, these are switches which automatically turn off when current in a circuit exceeds the safe limit. So these are about miniature circuit breakers, or MCB. Okay, so what is MCB? The full form is miniature circuit breakers. Next is CFL, that is compact fluorescent lamp. This is the CFL bulb that save energy as they do not produce heat along with the light. So in our common bulb, that is not a LED, not a CFL, so common incandescent electric bulb. Okay, that bulb, they produce light, but they emit heat also. But this kind of CFL, they not producing heat. That way we can save energy. Light is also energy, heat is also energy. So when this CFL, that not producing heat energy, so that the same way we can conserve or we can save the energy. Then next is ISI. ISI stands for Indian Standards Institute, which standardize all electrical appliances. So when you are buying any electrical appliances, you will see this ISI mark. That ISI, which is an assurance of conformity to the specifications given on the products. Okay, so all of you, when you are buying any electrical appliances, just see ISI mark before buying. Okay, so these are the things we have to study today. So all of you read the textbook and watch the video also. Okay children, so thank you, all the best.